Good story on Mars.
Yep, indeed, a good story. Very simple one, basically, but especially as it's Mars Week, it's worth noting that the Perseverance rover, Percy for short, has been trundling around Jezero crater on Mars, collecting rock samples, and it has now collected sample number 7. And everything seems now to be going well. There were problems earlier. You maybe remember we talked on an earlier show when some of the samples got stuck in the mechanism and they had to try and get them shaken out, which they eventually did. So they've now drilled a very nice, neat sample from another rock on the floor of the crater and stashed it safely on board. It'll be in a sealed container, and as I was alluding to earlier, that will be one of the samples that hopefully will be brought back to Earth at the end of the decade, early next decade, by the sort of the final part of this sequence of missions, the sample return mission. So nothing terribly exceptional about this, except that they're all different samples, different types of rocks. The thing about the Jezero crater is that it has an ancient river delta flowing into it, obviously caused by liquid water at some stage. So it's a prime site for the possibility of relics of ancient life. Very, very simple life, obviously. We're not going to find dinosaur bones or anything like that. So it's going to take one more sample in that area, and then it's going to be heading back more or less towards a space station, but going via the actual delta of the ancient river. And that's probably the most important site of all in terms of being able to find what may be samples with fossils of ancient Martian life. So Perseverance, good news. As I said, there were a few hiccups at the start. It's being guided by the amazing Ingenuity helicopter, which is a story in itself, of course. But it can get up and get a good view of what's ahead and say, right, there's something worth investigating over there. And assuming nothing goes wrong with the drilling and the sample collecting, there'll be quite a few dozen more samples altogether by the time this mission is ended. So that's number 7. Lucky, if you like, March the 7th in Mars Week. Well done to Perseverance.
Absolutely. And it's one of the missions, again, that it needs to be lauded. The descent EDL system on this was only the second time it'd ever been used, and again, absolutely nailed the landing. And it's been delivering fantastic science. The problem, as Terry just alluded to, is that there was a whole sequence of missions designed to collect these samples. Now, it's interesting. You're drilling core samples and then you're putting them in tubes. Obviously, because you don't want additional exposures to the Martian surface. If you're drilling into the rocks, you want to keep the samples pristine as possible, etc. And it will be the first time. I've got Martian meteorites behind me. Martian meteorites are not 10 a penny. They're not common, but we do have many examples, especially from the Allen Hills region. The most famous one, ALH 84001, which was discovered, and they thought initially there could be microscopic microbial life in it at one point. And you got Mars meteorites like Black Beauty, NWA 7034, etc., which are all really famous examples of great Martian meteorites that show evidence of this water kind of percolating through Mars in some point in its distant past. So it's not speculation. We've also got, as Terry said before, the Trace Gas Orbiter, which is looking at, along with some of the surface operations, looking at this methane issue, because that again is another big kind of weird one as to what the heck's creating the methane on Mars. We talked about that many times in the past, but I think this, and we'll move on now to the Ingenuity story as well. This, between the Mars samples and what this incredible little helicopter is doing. So this was it was designed as a kind of like a proof of concept, about a test thing that they were going to maybe fly 5 times over the course of a month. That was the whole thing. It says it's at 19. It actually, as of today, is now up to 21 flights. It's incredible. This thing uses solar power, so it's got no consumables. So it's not like it's going to run out of power packs or energy, etc. And bearing in mind how thin the Martian atmosphere is relative to anywhere else, it's astonishing just to see it fly. And the fact that they've been taking high definition video of it taking off from the Mars surface pretty much since it started this about a year ago. it's incredible. And JPL have now said that I think they said it's travelled 370 meters during its latest flight, which is 21st flight, 129 seconds. It's travelled nearly 5 kilometers since its first flight. 5 kilometers for a 1.8 kilogram helicopter that's tens of millions of miles away, and is doing this autonomously, and is now providing real scientific input to the rover. So the idea was just to test it and to see if they could fly as a kind of, maybe for a future mission we'll put something bigger on the surface of Mars, or potentially if NASA goes back to Titan, with the European Space Agency obviously having the Huygens lander on the surface, if NASA and or ESA were to go back to Titan and go with a submarine, they had plans for what's called the Kraken Submarine, to go into some of the methane lakes, but also to have a helo on a helicopter, helos as we call them in the defense sector, but helo on Mars and also on Titan, where the atmosphere is so much thicker. It'd be absolutely incredible. And this, as I said, it's a technology demo. This wasn't ever designed to be doing what it's doing a year later, but it's like everything that NASA seemed to do with the surface of Mars in the last few years. They said it was spirit and opportunity. Oh, we'll be lucky if we get a few months out of it. And then we go for best part of a decade plus. So they are extending the mission again, and it's now scouting ahead, as Terry said, into this river delta region. And this isn't just the NASA teams that are doing this. Kieran Hickman Lewis in the UK's Natural History Museum. So he's one of the scientists working on Perseverance, and he said at the conference that Ingenuity had basically been really helpful. I'm just quoting him here, in negotiating one of the regions called CITA, which is a region that's not optimal for rovers. And let's not beat about the bush. Spirit and Opportunity. We all know about sand traps and the issues that those rovers have had in the past. And we've seen the wheels, on many of the Mars rovers and how they're getting trashed. So this ability, even though they've got high rise in orbit and high rise, the high rise camera is staggering. I mean, it's able to image the rovers from orbit quite easily. It's picked up a lot of the remnants of other missions like Beagle 2, etc., on the Mars surface. It's really invaluable having something that can literally just fly ahead saying, well, you've got this problem here, you've got this problem here, oh, that region there looks interesting, and then to use the various instruments that they've got on the rover to analyze the rocks is just amazing. It really is. And the other really, really cool thing about this is using what's called COTS technology. So this is common off-the-shelf technology that JPL have literally put together into a helicopter. This is not something that they've had to cook up from the ground up. They've literally used off-the-shelf components and parts. And that goes back to what I was saying before and alluded to before about the whole use of common technologies, integration that is a lot more streamlined and simpler for the future. And I really, really hope that this is not the only example of this kind of mission moving forward. I don't know what you think, Terry, but I just love
Absolutely.
Yeah.
I didn't think it would be possible, given the thinness of the atmosphere and the fact that it wouldn't have a decent power source to power really big blades, but they obviously did the calculations right, and it's working. See, there's a question there from Jamie about what sort of data Ingenuity is gathering apart from imagery. Because it's so light, it can just basically take photographs. It hasn't got spectroscopic or any other sort of analysis. But because it can take images from a whole lot of different angles, that's giving a sort of a 3D view. And the images themselves then can be analysed in considerable detail back here on Earth. But no, it's not taking any other actual scientific measurements, just the pictures. But the pictures are invaluable.
Yeah, absolutely. I mean, there's another comment there in the thread about the imagery and how it's able to kind of see behind some of the rocks as well. And, this ability to really get in-depth. I mean, don't forget, even with a mono camera, even not with stereoscopic cameras, you've got this ability, if you were to just alter your position by a few feet, to take stereo images and do compositing. And that kind of capability combined with, what it's able to do. And another comment from Robert in the thread as well about the recharge. You only have to look at, modern phone technology. And as I said, it's using COTS technology. How many recharges, how many cycles, who knows? They just said they're going to push it until it dies. I would imagine, if it's been going for a year now, and it's obviously going to be a trickle charge. You've got a relatively small solar panel, relatively lightweight, relatively small helicopter. It's going to need to charge up, and obviously it's got dust issues, like all of the rovers that have used solar panels in the past. Spirit and Opportunity in particular, where you look at the dust gathering, especially with dust storms, and then sometimes the dust storms will do you a favour and actually take the dust off. So large buildup of dust, you're going to, not have non-optimal solar panels. But I would imagine, unless something fundamental breaks in it, I would imagine it'd probably be more like a gearing system, or maybe the gyros. Something could fail. A bit of dust could get clogged in there. That's more likely, I think, going to be a failure point for this. But we can just wish it well and just keep going. It's amazing. And watching the science team, especially during the depths of the pandemic. Don't forget, this was starting its mission then, and the science team all massed up in a room, visibly quite separated, just so excited about this. It's fantastic to see. So long may ingenuity kind of keep going. Just to say to everyone who's in the chat thread, thank you so much. You've got some brilliant comments, brilliant questions. We love it. Just keep them coming. There's also comments about when we're going to see feet on Mars, ground, boots on Mars. We've got to get boots back on the moon first. That's only 250,000 miles away. And, we were going to talk about Artemis and SLS and the cost of that, which, what the auditing office had come out with some astonishing numbers for the launch costs, which I've been having various arguments with people from Boeing and other very, very notable and very respected science commentators over the past week. And, anywhere between 2 and 4 billion per launch. Again, that model's got to change. That can't continue. When you're up against the likes of Elon Musk, you can't be charging or costing $2 to $4 billion for a launch.